A matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns enclosed by brackets. Each item in a matrix is called an element, and its size is determined by the number of rows and columns. There are various types of matrices such as row matrices, column matrices, square matrices, diagonal matrices, and identity matrices. Using the provided score and weights, calculate the final weight average grade for each student. Additionally, represent the data in matrix form and perform matrix multiplication to derive the final grade for all three students. Step 1, we have to write it in matrix form. First, create a grade matrix A for the student and a weight matrix B for the grade component. Next, in step 2, we have to verify the compatibility, and then we can perform the matrix multiplication. Review that Alexandra achieved the highest grade due to her strong performance in tests and projects, which were the most heavily weighted component. Brittany secured a balanced grade by performing consistently across all assessment categories. In contrast, Megan scored the lowest, primarily due to her weaker performance in tests, which had the highest impact on the final grade. This highlights the significant influence of test score in the weighted grading system and underscore the efficiency of using matrix multiplication to account for varying weak systematically.
Introduction of complex number. A complex number is a number that consists of two parts, a real part and an imaginary part. It is usually written in the form z equal a plus bi, z equal a plus bi, where a is the real part, b is the imaginary part, I is the imaginary unit, defined by I2 equal negative I2 equal negative 1. Complex number can be add, subtract, multiply, and divide. Following specific rules, they are used in various fields such as engineering, physics, and mathematics to solve problems that involve square roots of negative number among their application. Problem statement of complex number. Here are a problem statement involving complex number. Problem statement. Solve the for z in the equation. Solution approach. Express the complex number z as z equal a plus bi, z equal a plus bi. Number 2, substitute into the equation. 3, separate the real and imaginary parts and solve for a and b. This is a typical problem in complex number algebra where you need to isolate the unknown complex number. Result and discussion complex number. A real number and imaginary number make up a complex number, which is essentially the combination of the two. The formula for the complex number is a plus ib, where a presents a real number and ib present an imaginary number. Additionally, a and b both real number and the value of I is a negative one. A complex number is an easy way to represent the addition of two numbers, namely a real number and imaginary number. This is because a complex number is simply the addition of a real number and imaginary number. It can be broken down into two categories, the purely real and the purely imagined parts.
The most common example in differentiation is the rate of change of displacement with respect to time. The general expression of the derivative of a function is represented as f prime x equals to dy over dx. In this question, we need to find the rate of increase of the area of the segmented when r equals to 3 and theta equals to pi over 4. First, we must find the area of PQ and the area of triangle POQ. Then, we differentiate the equation with respect to t. After that, substitute r equals to 3, theta equals to pi over 4, dr over dt equals to 2, and d theta over dt equals to 0.1 into the equation. From the result obtained, the rate increase of the area segmented is 0.602 cm per second. Based on this question, radius and angle will affect the rate of the area segmented.